All right, this is part 2 of the first lesson in chapter 2, and we just have a little bit to finish up here on the first page. We left it trying to figure out the end behavior. So if you look at this graph, remember we're looking at the positive, the pink one. As the x is approaching negative infinity, a very large or a very small negative number over here, what is the behavior of the graph? Well, the behavior is approaching 0. As it's approaching, x is approaching a positive infinity, the graph is also approaching 0, the end behavior. Okay, you had one little bit, another graph on the second page, and I've prepared that, so let's go ahead. If you can cut that out, tape that in. We will also look at this graph. Now, do you remember when we did parent functions, and we had something called the reciprocal function? And you also had the square root function, right? So if you have here, if you have 1 over n, and n is even, that means 1 over 2, square root, fourth root, that type of thing. Then you are going to have part of a side parabola. Remember, that's the positive side. This would be the positive branch. But if you have a negative coefficient in front, remember, let's see, we did that in blue, then it would come below the x-axis. So remember that. Now if you have, instead of a square root or fourth root, let's say you have a third root, fifth root, it's odd. The root is odd. Then instead of the sideways, the positive snake is if you have a positive function. But if you have a negative function, negative coefficient in front, then you're going to start high and come low. Otherwise, you start low and go high. All right, let's identify some of these characteristics. So let's go back and look at the even. So square root, cube root, or fourth root, sixth root, that type of thing. The domain here, the domain is from 0 to infinity. The range values are also from 0 to infinity. They are positive. The x and the y intercepts, right? We are starting at the origin for these. Remember, this looks like I just have all these points listed, but remember the first two are intervals and these are actual coordinates, the coordinate of the origin. Is this function continuous? It is. Does it have any symmetry? Okay, can I just flip that function? No, it doesn't have any symmetry. It's not applicable. Where is it increasing? And where is it decreasing? Well, it's increasing in the whole graph itself from 0 to infinity. Okay, it's never decreasing. Let's look at the end behavior. As x approaches a large or a very small negative number, that doesn't exist. That end behavior does not exist. But as it approaches a very positive, large number, as x gets larger, then it also approaches infinity. So now let's look at the cube root, the fifth root, any odd root. This domain, okay, of that function would be all reals, right? Negative infinity to infinity. And the range as well can be all reals, negative infinity to infinity. The x and y intercept as well is also 0. It's at the origin, 0, 0. Is it continuous? Yes. Does it have any symmetry though? Does the odd root have a symmetry? It does. And it's symmetrical to the origin, which makes it odd. Is it increasing or decreasing? Upon what interval? Okay, remember you're riding it like a roller coaster. So you're coming in here, you're going up, you're going up, you're going up. All right, it's increasing over the whole graph. So increasing would be everywhere, from negative infinity to infinity. And it never is decreasing. It's always increasing. The end behavior, the left side, as x approaches a negative infinity, what is the function approaching? It's also approaching a negative infinity. And as x approaches a positive infinity, the function is also approaching a positive infinity. All right, when we come back, we're going to talk about some radical equations, and we're going to do a couple examples. When you solve equations, you usually isolate the variable that you're trying to solve. Well, with radical equations, it's the same idea. You want to isolate the radical within the equation, and then raise both sides to the power of that radical, of that index, so that then you can remove the radical, so to speak, and then solve for the variable that is trapped inside. Also, you need to check for extraneous solutions when you're working these problems, because that determines, it indicates very often if you are squaring something, to solve, or you're cubing it. Sometimes the answers may not be all valid, and you have to plug them back in to see. All right, let's look at this example. 3x equals 3 plus the square root of 18x minus 18. So I've got two x's here, and I need to try to figure out how to solve and get them together. But first, I've got to isolate this. So I'm going to kick this 3 to the other side, which will give me 3x minus 3 is equal to the radical of 18x minus 18. And now I'm going to remove that radical, and I do that by, it's a square root, so I'm going to square both sides. When I square both sides, you need to remember that this is 3x minus 3 times 3x minus 3. So the first one will be 9x squared, and then you're going to have 9, or negative 9 and a negative 9, which will give you a negative 18x. The last term will be a positive 9, equals, and when you take the square of a square root, you're left with the value that was inside. We're getting closer, right? So now I'm going to bring these terms to the left and isolate the x and see what I can do. So I'm going to move both of them over here to the left side. I'm going to subtract 18x, well I already have a negative 18x, and I'm going to add 18. When I do that, I will be left with 9x squared. I will have negative 18, and negative 18 is a negative 36x, and that would be a positive 9 plus my 18, which is a positive 27. Well, I look at that quadratic, and we know several ways to solve quadratics. Right? I also see that there's a common factor within this one that I can pull out. So I'm going to factor out a 9 out of this, and it will make my life a little easier. So I have 9 times, I have x squared minus a 4x. I factor a 9 out, I have plus 3. Now when I can factor what's remaining, and I will have 9 times, can you see what those factors are? I'm going to have an x and an x. I need a 3 as my last term. The only way to get that is with 3 times 1. And I need a negative 4 in the middle, so that negative 3 and the negative 1 need to both be negative. Does this give me my positive 3? Yes, it does. So then my solutions become a positive 3 and a positive 1. Now if I plug those back in, do I still keep this value in the square root positive? Yes. I mean, one of them gives me 18 minus 18, which is 0. I can still take the square root of 0. I just can't take the square root of a negative. All right? So those values do work. All right, let's try another example. Example 2 says the cube root of 4x plus 8 plus 3 equals 7. So remember, we want to isolate this radical, so we need to move the 3 to the other side. If I move the 3, I'm going to have the cube root of 4x plus 8 equals 4, right? I'm going to subtract 3 from both sides. And now to lift the cube root, what do you think we're going to have to do? To lift the square root, we squared it. So to lift a cube root, we are going to cube both sides. Perfectly legal. When we cube a cube root, we are left with that 4x plus 8. When you cube 4, that's 64. Oh, look, this is working out nicely. So if we subtract the 8, we have 4x is 56. So x is 14. Very nice. Right? If you look at example 3, this one's a little odd. All right? This has got a square root both sides. All right? Still, to lift the square root, we need to square it. And we can't isolate both of them. If I put both square roots on one side, then I can't get rid of them, and it makes a much bigger mess. So we're going to leave one of them on the side alone, and we're going to square both sides this way. And the right side's going to get a little hairy, but that's okay. We square the square root of x plus 7, we get x plus 7. When we square this side, remember this is 3 plus the square root of 2 minus x times 3 plus the square root of 2 minus x. So we have to FOIL this. So the first term is 9. The next term is going to be 3 on the square root and 3 on the square root. So I'm going to have 6 on the square root of 2 minus x. My last term, it's kind of nice because it's the square root of 2 minus x times the square root of 2 minus x, which means the square root goes away, and I just have 2 minus x. So let's clean this up a little bit. Now, if you'll notice, we are down to just one square root. I've got lots of x's, but one square root. So let's combine everything and get the square root alone on one side. So we're going to bring, let's see, 9 plus 2, that becomes 11. So I have an 11 plus 6 on the square root of 2 minus x minus x. So I'm going to bring the 11 to the other side, and I'm going to bring that x to the other side. So I'm going to have x, this will be plus x, so I will have 2x on the left. I will have a 7 minus 11, which will give me a negative 4, and that will equal my 6 on the square root of 2 minus x. Now I'm pretty good. I can take this and get rid of that square root if I square both sides. And I think I may come close to running out of time, so we'll see how far we get here. Square this, and that's, remember, that's 2x minus 4 times 2x minus 4, so we have to FOIL that out. That becomes 4x squared. This is going to give me a negative 8 and a negative 8, so I got negative 16x. My last term is negative 4 times negative 4, which is a positive 16. Then I'm going to have 6 times 6, which is 36, times the 2 minus x. The square root went away, but I now need to also square the 6. And I am going to run out of time. So let's just distribute this real quick. That's going to be 72 plus 36x. And I'd like you to try to finish that on your own. And we will finish up this last little bit of example 3 in class. Thank you.